So we'll stream in a couple of seconds. Meanwhile, why don't I start sharing? Let's do this. Wait for a second that I have the window so I hear myself. Okay, it's on. Okay. And so I don't know if you guys submitted already the files, the scripts. As you can see, Jeff and Emily are in the build lab, and I think that we can make use of this time together, this live session, also to take a look, for them to take a look at the files, at the scripts, and maybe reach out to you in real time, just to, to fix things and to make them work for the digital fabrication part. So should we kick this off? Misery, you agree?
Yes,
should we just look at
absolutely. Let's get started. It's great to see how fast they're picking up. Like, we could complete a semester worth of stuff with these guys in just about 2 weeks. So that's amazing.
Yes. So, guys, is this too much? Today's the last effort, and hopefully this week was very productive for you, so that you have a lot of material that you can use, and we can start here. Is Alma's here?
Oh.
Yeah, I think. Yeah,
is that
you
your
the
first name?
one.
Hi guys. So yeah, so it's Muhammad Almas. Muhammad is like prefix. So my name is Almas.
Okay. Sorry about that.
So this is our cube. So what I try to do here is, if you simply see the hot wire cutting is basically a single line. And if we are cutting that multiple points, it should be in a single line. So we can cut like a single curvature only using the hot wire cutting. But if we take perpendicular sections of attached parts, and then if we draw like, different interpolations into that, then we will be able to achieve this kind of geometries where there is double curvature, and it will be of different radiuses. You can see like the first, the 3D view is like a very steep curvature, and then it is decreasing. So that was the entire idea, whole concept. It is made out of 6 planes in 6 perpendicular planes in cubes, front side and top side. I have mentioned like 1, 2, 3, 4, 5, 6, and the previous slide. So all planes are like how they are cutting. It's like the demonstration of that. And if you merge everything's trajectory, then the next slide will be like, this is the merge trajectory, and this is the final art piece.
Look at this dance of the robot, really. It's very fluid. What is compelling to me to look at is really the form, and how, I don't know if you had something specifically in mind, but really, like, if I look at the second one, I think of it as a positive space, like a built space, while like sometimes, like for instance, this element seems more a negative. So like
that was the idea. That was the idea, to combine both curvature. Like I mentioned in the last previous class, that I'm more into like, I'm developing reconfigurable modes. So more into like anticlastic and synclastic curvatures and the possibilities of that. So that's what I'm trying to explore here.
Oh, that's great. I think it would be really interesting to see this actually like deployed in the next step, and try to use this as the negative space and cast plaster and see what happens, and tweak things, and rotate this and see what happens. Even if you don't work like only with 90 degrees rotations, but you try really to position that let's say 45 degrees in the space, and see what happens in the resulting, like in the gaps, in the relationships between the the container and all the gaps that you will create. I think it's a very interesting exercise.
Yeah, and the great part is, even when you cut the piece out, in my head, like especially with the remainder of how you cut the first piece, which has like this steep curve. In a lot of ways, that also becomes not as something you throw away, but something that could potentially help you convert or transition to a next block if they
Yeah,
were to
exactly,
sort of
exactly. So that
continue.
was the idea. Like one curve, and then the perpendicular curve will make it double curvature. Jeff asked that whether it is touching the middle thing or not. It's not. I've checked it in simulation, but I don't know. You need to check it like by your end. But like in the simulation, it is not touching it. I have faced one problem actually when we were merging like all the trajectory of 6 planes. Handling those were very difficult. So what I did is I took like 2 planes at a time and then try to like create a path, and then like the first path I disabled, and then like subsequently I try to manage it like, you know, taking 2 trajectories at the time. And then if you'll accumulate, you will get the results. That's what I found out.
Oh, that's a smart idea. Did you have to add add more sort of heights for the Z offsetting?
Yeah, so like this next one is based on like the previous path. Then I can change like X, Y, and Z. That was like pretty simple. Earlier, like for an hour, it was like, you know, so messed up. And I tried to like use it with 6 planes.
Yeah, well, you
Yeah.
crossed that hurdle.
And I was laughing a second ago because I saw Jeff very scared about about this, but we'll make it work. I'm really excited about this. Let's see
Yeah.
if we can implement this by the end of the day. Jeff, are you laughing?
Is he
Are those
laughing?
files already on Google Drive
Yeah,
so
I
that I
have
can check?
uploaded that.
Okay, awesome, thanks.
That's it. Thank you guys.
Thank you a lot. Very fascinating work.
All right, up next, Espartaco.
Spartaco, let us know.
I love your name.
Good morning.
Good morning, guys. I just woke up.
Getting coffee?
Yes, yes. Here are the coldest days of the year are just this week. So if you see me with my with my hat
Really?
or the coffee,
Where are you joining us from?
I'm in Argentina right now, but I'm moving in a couple of months to Spain to the Barcelona, the IACC, the Institute of Architecture from there. So to do
Awesome.
some courses or robotics there. So well, my work was about doing this parametric pillar that was inside a cube. Took me a lot of hours of coding, but I did it. I had this kind of like idea, like doing 4 cuts, the same cuts, but rotating 90 degrees. And so my goal was to be able to modify parametrically that cube and impact it directly on Bianco's toolpad. So I did a lot of tests. So it's a simple process, but the coding was difficult because I had rotations on the form that later on the robot seems to be harder to make
Control.
clear without cutting the cube. So if you see in the cuts, you see that I put an out point from is one cut and out point up in the cube, and then the rotation of the hot wire doesn't cut the cube until the next cut. So I chained like 5 cubes and seems to be okay. and with no errors to the robot. So my inspiration was this kind of concrete pillars that are umbrellas here from a Uruguayan architect in 1939, but this is like kind of my idea of exploring with this uh, with this work. So the next one is like uh, 1, 2, 3, 4, 5, 6, 7, like 8 pillars of the same cut. So I please, Emily and Jeffrey, don't kill me with this one. So well, that's it.
And actually, the thing is, we haven't introduced yet a rotation platform because in this case, basically every cut goes like with a rotation of 90 degrees. And you
Yes.
imagine like programming one cut and then you can rotate the platform and then you do the same cut over and over, right?
Yes.
By
Uh-huh.
rotating. So
Mm-hmm.
it's sort of thanks for like explaining, talking about the difficulties in fixing all the rotations and the scripts and the script. Yeah, but it's also our limitation in terms of like the hardware that we are using right now. But I think the
Mm-hmm.
next step is really like to look into rotations and try to simplify some operations while using the algorithm.
Well, in this case, the rotation was uh, four sides. I I didn't
And more
think in
challenging.
yes, I didn't think at the time that it was about to be difficult, but I don't know. I leave you guys, Jeffrey. Don't kill me, please.
Oh no, I think this is a really great way of approaching it because it keeps the four sides planar. It twists the wire, but in a way that we know is going to be predictable. So I think it's a
I
really simple and really smart way of approaching this.
Yes, I tried to keep the the arch vertically on all the cuts. So it took me a lot of time to figure out how to do that, but I managed to finally present this. So I leave you guys with the files.
And one quick question: was this like the max amount of twist that could possibly happen? And if you were to twist, say, either the top or the bottom curve slightly more, it would start self-intersecting?
Well, I tried the parametric the parameter has like 180 degrees,
Mhm.
like a flip,
Sure.
but this form is like a nicest approach for this, but it can turn more, but the middle section has to be uh, bigger because
Right.
when the form you want to do smaller section in the middle, the rotation uh, uh, it's more like is make smaller the middle section,
That makes sense.
but it kinds I rotate one piece or an 180 degrees, so
Mhm.
like a flip, and it turned out great. So I think it may be, but taking it further, I don't think so because the form or the cube has to be like 3 cubes for the rotation to be not to not to break the form.
Yeah. No, that's great to see because even with one of the references Sarah showed yesterday, which was from Matter Design, but it was a huge tower. So that also
Mhm.
means if you were to like really scale it up to like 3 stories, there could be potentials to sort of,
Yes.
really break it down just the way you show your sort of red lines right there, right
Yes.
here. So even if at a building scale, if we were to produce it, we could, I think most likely be able to pull it off. So it's great that you're thinking between two scales as a 6x6 model versus how to scale it up. So kudos to that.
Yes, I think when the form of the phone is higher, then the robot will be rotating like on the side, not from the top. So I don't know if the form is higher. You have for the robot being up of the cut, you have the height of the arch for cutting. So I don't know. I think that the scale of the model has to be a lot of smaller to present like more rotations from it. So
it's also great to look at the approach. Like thanks for picking up on this strategy we're suggesting, like to imagine this larger scale with diagrams, with the simple rendering. I think it's very effective, and hopefully for like in the last assignment, in the last exercise, you will feel more relaxed in terms of like you won't have to solve every single rotation and for implementation. So you'll have like slightly like a measured degree of freedom. So hopefully that will help you guys being like going through the last part more smoothly. But thanks for this. I think it's very compelling. It's great to see, like to have the possibility to talk in different scales about this. Good job, Spartaco. Love it. Wow, Heniel.
thanks, guys.
Thank you a lot. You're next. I like this.
Thank you.
How many? Okay, one slide. Okay.
I
almost
wanted
want
to
you to pour plaster in that already.
Oh my God, yes.
I wanted to just experiment the rotation of creating a wavy surface, and it was really hard to just organize it somehow that the robot doesn't have any error, because I rotated the surfaces, but I think I should work with the plans more to find the best approach that robot doesn't face errors in case of other surfaces. And yes, I think these curvature faces looks nice in the box. On the box.
Am I the only one imagining like this material being gold? Like really gold pouring, gold surface. It seems like a jewel. It's like a piece of jewelry. It seems so precious from these images.
Yeah, for sure. A couple of days back, I'd seen a project where essentially the cube was, I think, made out of concrete, and your yellow part was like cast bronze or brass or either of the two, and they were using that as furniture. So I think it has a really good product feel to it.
Absolutely, and also like really, yeah, there are many ways to look at this. Seems that the inspiration comes from, you know, the Grand Canyon. Like seems like really a piece of rock carved by water over time. Like kind of seeing this these layers of rock being sort of like bio inspiration that drove this design. I think is fascinating. And also, yes, really like thinking it's interesting to see this, in which you have like a couple of like just smart moves, 1 and 2, and then you really can picture also the negative space and imagine that, and maybe like flip your object and it becomes a building that has some interesting sort of like sacred kind of thing, like moments that you can discover inside when you get into this space. I think, I don't know, it's guiding me through many worlds. I don't know, of imagination somehow. Yeah, good job. It's great. And I don't know. I'm trying to see the reactions from the B Lab as well, but since things are quiet there, I don't know. Let's keep going.
For the last one.
Have you seen this one, Jeff?
Oh yeah, I saw that one. We're gonna have to take a real close look with the slider for potential collisions as the bow kind of moves. Like from the pictures on the left, the yellow highlighted parts, one of them seems clear enough where and how it moves through, but I can't quite picture how the other one comes out. So where the pointer is currently, there's kind of the line that goes diagonally across the top edge, and we see kind of parallel lines sinking down in, and then I don't know how it twists and comes out that vertical edge in the front. That part doesn't totally make sense to me. And then the slice on the right hand side of that cube where the pointer is, that one seems a little bit more clear where it goes in and how it comes out. But that one on the left is really confusing to me, and we'll have to take a close look.
Yep.
The left one is similar to the right one, just because maybe I should put the other perspective of the cube to be more clear, but the right one is almost similar to the left one. They have similar approaches and also similar curves, but with a little differences.
Okay. I can't really I don't know how to use my pointer or draw in here like Misri does really well, but if the wire enters the front vertical edge and then kind of pivots around that front lower corner, and then when it gets to the back as a diagonal line, changes and pivots around the top back corner as it comes out, then I can kind of picture an entry and exit for that one. But like I said, we'll just have to take a real close look.
Yeah, it almost feels like, since, well, I'm trying to imagine what the division points would be, right? Because is this how we're dividing it? So is this how it's sort of, yeah, just like that? I have a feeling once the wire does start to do that, it's gonna be true to this line right here and this line right here. But
yeah,
what happens with the surface would be a resultant of the tool path. And I have a feeling that might not necessarily match what we see on this digital space, just because the curve right where the cursor is, this one seems to be longer than the other one, or maybe it's the other way around. But just the fact that we're trying to use the input curves to sort of merge the two lines, almost join the two lines, and then extract the midpoints as the plane to sort of align with the wire of the cutter. I think that might give us a slightly different geometry, but it's definitely worth a try, because this again sort of adds that notion of the limitations of a tool, but also how do we simulate that to get a better handle on what to expect.
Mm-hmm.
But it's definitely worth the conversation to sort of take it forward.
Yeah, absolutely. So thanks a lot for your work. So who's next? So let me see. Slides.
That's
okay.
my work. That's my work. Hi, everyone.
Hello.
In this practice, I try to make a architectural space. I create an empty space in the middle of this cube and chamfered the corner of the cube with different degree. I mean, I cut it. And in that, in the next page, I create at the right side, I create the public space that emphasize on a tree. The shelter people gather together and speak and talk. And this modular tower, I try to use the cutted other side of cutted cube That's a connection between the module of the tower, and the cut pieces are the floor on the of the central courtyard. I say that central courtyard in the middle of the tower, and that's it. It's my work.
Wow, you really deployed this notion of stereotomy that we described yesterday in terms of really working simultaneously in two parts and then they can come back together. That notion that it comes from like the craft of cutting stones, right? And so it's really, really effective to see this approach deployed in a way that we can see both spaces, and we can see the positive and the negative of the same geometry, and then we start to populate the space with these elements. I think it's, yeah, again, just sort of like a deterministic approach in which you are trying not to waste resources and to create the most out of it. I think it's a very compelling example.
Yeah, I can almost imagine sort of concrete being cast in this, or maybe this is coming from seeing one of SOM's. It's funny we call it stereo. I think they're also calling it stereo form research lab, where all they did was, it was like this sort of going around as one, as against what you're doing. So it was just another axis. And this was actually cut out of foam, the negative was, and then this is where concrete was cast to sort of, but again, they were also, I think another good dimension to add would also be to justify why sort of this junction is thinner than the other one. So, I mean, I guess a few structural qualities come into play to sort of say, maybe doing this gives you longer spans or something of that sort to really start optimizing the form. I'll be sure to drop a link to that project, but this comes super close to that. And also it's good that it's challenging methods of production on construction sites and, and pushing the boundaries of what's really happening on site right now.
Yeah. And Vahid, in terms of scripting, how was it? Did you have specific difficulties?
What I don't understand.
Was that easy or was that difficult to script? Like to
No, it's that easy. I more than write the curve in the Rhino, and I export that in the Grasshopper and simulation with that robot. It's not so difficult to me.
Great. So you optimized literally everything from the design to the this notion of use of matter. I think it works pretty well. Thanks a lot for your work. Hello. Let me see how many. A couple. Okay, thanks.
Two slides. Yes, it's very, very simple works. It's just simple curvy cuts to understand how can we organize it. But I have a little bit time constraints, and also it's a little bit challenging for me right now for Grasshopper. So sorry for that, but it can be.
I think it looks
it's just
great.
an introduction course, so
yes. Plus, like simple doesn't mean that it has less value actually, and you put here a very.
Yes.
What's the inspiration? Solevit. Yes.
Yes. Solevit, I think it's very inspirational for these hot wire cutting projects, especially this work. Maybe so we can maybe I can do find a rule like that, but at 3D on 3D level to upgrade this project.
Yeah, absolutely. What we have tried to do when I showed like those references, Vera Molnar and Solevit, those are very 2D concepts, and then we try to do the same, really, like just to translate those into the 3D. I didn't use another reference, Rowena Reed, that actually sort of like does similar approach, but like using iterations to work on a cube, and to, and you know, like one of the exercises that came from her process was to really carve cubes so that when looking at them, they seem bigger. So this was the exercise, trying really to work on the matter so that you had a totally different perception of geometry. And so, yeah, I think it's just a good way to translate from 2D to 3D, and to have also a sense. And again, that was the requirement, basically. Try just to imagine sort of a spatial kind of condition in which you assemble these elements, and you create space, again, in 3D.
That's a good puzzle
Good job.
exercise too, right? Because every time I look at MC Escher's staircases, or just the drawings he made, it always puts me in a weird space where I'm trying to figure out the 3D, but cannot really do that fully.
Yeah, absolutely. So good job. So how was the scripting? What was the most difficult part for you to understand the rotations, or in general the Grasshopper language?
Yeah, I have an error for Kuka PRC because but I couldn't manage to solve that problem right now because it's hitting the box. The robot is hitting the box. Maybe I can work with planes to solve it.
Yeah, but so it's a good start, and so hopefully now you understand the process, and you can try more things in the future. So it's really, as Misri said, it's an introductory course. It's for you guys to understand the logic, to understand the tools, and then to play with those in the future. So hopefully we managed to transfer this to you guys. Last one.
Yeah, this one's mine, and I didn't manage to finish it. Well, I wanted to play with rolled surfaces and check whether the robot could reach like all around the cube. It turned out it couldn't, but I think I learned a lot, and thought that I could upload it here to maybe give some courage to anyone who didn't manage to.
How can we solve this with just dividing in half and then rotate the pedestal, rotate the cube? What do you guys think? Because actually, yeah, go ahead.
I would say first idea was dividing the cut path into two planes. Like if you're trying to wrap all the way around the form with a single plane, it really, really limits the movements that the robot can make. So dividing it into several planes that allow the bow to come out. Maybe it needs to rotate 180 degrees and then return to a certain point. So if it were split into, I don't know, at least two, but some number of planes, not too many, but that might help alleviate, because it's gonna, I think, need to make some motions where it kind of reorients itself. If you wanted to try and make a single swooping thing, the other thing could be just maybe same form. I don't know if it was designed in Grasshopper and it's parametric or something like that, but if you could change the angle, that might, in this circumstance, help because of the position of the pedestal relative to the robot base and how much reach is necessary to get around. I think that maybe if it didn't have to go quite so far, then it might be able to get it in a single sweep. So those are my two ideas.
Since it's vertical, I'm just curious if you tried putting it horizontally and if that changed anything.
Yeah.
Maybe I tried firstly to put it horizontally and cut it out from the cube. It was a little bit smaller then, and make something like better Zumthor, and to see the negative from the inside. But well, it was too difficult for me.
But are those? Did you upload those files?
No, not yet.
I think we can we can
take
try
a
to
look
work.
at it.
Yeah. I think we can work on this later and try to see if we can
Okay,
yeah,
so
as Jeff
I'll
said.
a little bit longer and send you the files, and we can fix it together.
Yeah. So today Jeff and Emily are in the build lab, and they will be available, to implement this. So I'll try to help you out so that you can have this object as well. Yeah, so let's try. So thanks a lot for this work, fascinating, and hopefully we'll be able to produce these things. Other comments? Otherwise, I'll go. We have 15 minutes.
I'm just trying to dig in because I think maybe 2 years back, someone was trying to pull off a similar project like we saw on slide 12. And I know they managed to do it. So I guess it's a matter of sort of rotating it in the right kind of angle to accommodate everything. But yeah, let me just dig in, and towards the end of the lecture, hopefully I find it and I can show that project to you, which was also at the same scale. So hopefully that just helps it.
Thank you very much.
Thanks, Mizri. Submission template, no. How about we go here? Then I have a couple of base files to show you. But yeah, let's start from this first. Let me do so that I can see the following slides. Here we go. Okay, so I'm seeing some comments from the build lab. We can discuss these things later as well. So we are approaching the last exercise, but I think that we have mentioned already certain things. I think you understand now. Actually, you have expressed already this approach of like showing things at different scales. And I really jump right into the description of the assignment, and then I'll show just some examples for inspiration for you. And again, you should be less stressed. There's less code to be figured out, and really you can imagine a very simple component and try to work on that however you want. So this time you can pick the end effector that you want. You know how to model an end effector. You know how to place it in the origin in Rhino. You know how to plug it into the Kuka PRC core. So it's really up to you, and show us another, and again, a new concept if you want. Or you can take something that you developed previously and add more examples of aggregations, or ways to use the texture on a wall, or really another architectural sort of scale application. Because what we're trying to do is to really to imagine that at a certain point, the next future, designers will go on site and will find robots. And in that case, designers will understand the language of robots, the procedures of robots, the sequences. And so that's why our ambition is always to try to imagine ways to scale up the process, the robotic fabrication process. And here an example, this is another exercise that we did a couple of years ago at COED called PNED, meaning trying really to understand, to engage with planes and rotations and geometry, and so dividing a surface in a way that you could reach each target point perpendicularly to the double curved surface. And I'm adding here like an example of dance choreography, because as we mentioned yesterday, we need to think about sequences. And so the sequences in space mean that you want the robot to reach the target points from point 0, 1, 2, 3, etc. Right? And so, and even if, for instance, we come back at the same point, anyway, that point will come as a result of a more complex sequence, right? And so, and this just try to imagine the sequences of understanding surfaces, understanding the space, understanding the implementation, the rotations at a larger scale. So this is the main concept.
Yeah. Also, if we just jump back, yeah, right here, I think this exercise is super interesting because so what the robot is really doing is it has a tool head which holds the nails and sort of goes to the surface and pushes it down. And what's interesting is we're using sort of this junction as the feeding sort of spot, right? So every time it goes down and places it, it comes back empty-handed. And that's where we're sort of, that's where even the human concept comes in, because it also challenges the notion of what can robot do by itself and where can humans be roped in, where a human can be like this feeder of nails at some point, because it's fairly repetitive, but we're also relying on the robot for precision. And I think you could also sort of, it's a good exercise to look at existing construction sites to see where the gaps are and where we could use a slightly more streamlined process with the robot, but not forgetting that humans also have the capacity to decipher and understand a lot more quickly, or sometimes react in a meaningful way. So I think we can have a debate over this process in general, and how, instead of saying automation takes over, how can we sort of leverage the strengths of both working parties?
What Matthias said yesterday, the humans can extrapolate better data, right? And add like the critical interpretation of these things. So yes, absolutely. So last effort, if you guys want to proceed with the exercises, what we're asking you is to speculate on the process and to imagine the realization through robotic fabrication of one unit, one element, and then imagine that at a larger scale. You can, if you want, if you have time, depends on on your on your life or your daily life, the time that you have at the moment. But you could imagine even multiple sequences of tasks of end effectors that can create together sort of a combination of outcomes, and then you put them together however you want. So elaborate a concept basically, and this time will be simulation. So we're expecting to see some provocative images on the Google Slides file. Produce a building component that could be part of something bigger. In a way, you are basically informing through a robotic process the construction of an architectural system.
I have one question, Sarah.
Yeah.
So my question is about like having an extra input to the work that the robot will be doing. Like if on the pointer it kind of like grabbing something at one point and lifting it over at other point, how that input enters to the Kuka PRC.
So
I'm not saying that you have to teach us, but just asking.
Well, we have a pick and place file available for you guys if you want to check it out. In that case, the end effector that you'll find in that file, it's simple because it's sort of like a vacuum sort of gripper, in which you are kind of like using air to attach like the object that you want to move in space. And in that case, you only use geometry. So you use, for instance, the center point of that object, you just reach it, and you are assuming that the end effector will basically pick it in one location and place it in another location. And right now, I know that the latest version of Kuka PRC can even visualize like the moment in which you're like, if you want to use like a standard gripper in which you're really opening it, closing, and moving an object. In that case, the simulation is possible. I haven't installed it yet, so I haven't tried that yet. But we can. So Misery is sketching something now, but
yeah,
really,
I'm just trying to think through the logic now that you mentioned it. So I'm just thinking out loud here, so don't have high hopes, but just trying to.
Yes, my question.
But yeah, usually it's geometry. It's a
Yeah.
geometry input.
My question was about if an extra hardware adapts to the Kuka robot. Can the software take it well, or you have to do it like a third-party app or from outside all the software? I don't know. I was thinking the other day like having this light pad, but on the LED light sort of turn it off in one point, moving, and turn it on and another point, and the software taking that information and simulate it. I don't know if that's possible.
Yeah, you can do that, and those are called external inputs, right? Like you can have internal and external.
Yeah, kinematics. Or actually, I've also seen people use Arduino with it. So I guess in a lot of ways, it happens as true and false. So the gripper sort of when it's supposed to sort of loosen up, it's false, and it goes to the brick, which sort of is generated from the centroid of the top plane of a brick in some ways. And then as soon as we say true, that's when it actually holds it, picks it up and goes to travels to another point right there, and places it again with the same kind of plane that we saw with X, Y, and Z coordinates in position. Yeah. And then true again sort of becomes false, which means open. So I guess you can almost think of it as your hand moving, right? Because you're going to a place, picking up the brick, which is false. You go to another place, place it in position, and say true. So that's when you sort of release it, I guess.
Yes, when you are managing like a G code of a CNC machine, you actually can go to the to the line of code, detect that part of the movement, and add an extra function to the machine. I don't know, like if you have a hot end that is putting plastic, like printing something with plastic, you can turn it off, like the input of plastic in some point, and then move and in on the other point. But I don't know if the G code of the Kukas can be read as G code, or is like another sort of file, totally difficult to interpret it.
No, I don't think so. There are ways. Yeah, with Arduino, I think is the most common way to do that. Just imagine that, like the grippers, for instance, they have an electric input, and through that you can send information through the scripting. In that case, really, when you have an electric input, then you do this true and false, and you open or you close the gripper. So that's how it works. And you have a way to connect these two things, but you have like there's another level of programming, like with Arduino or with Python even. But yeah, you can do that if your end effector is connected really with the Robo hardware. So yeah, the response is yes. We'll show you like the easy part later with the pick and place, but and I can try to find also the component that says that you can have external input.
But if your question was going towards like what's expected from this exercise, say for instance, you were projecting a workflow, we don't have to figure out how it'll work. It's just, I think we're also taking this opportunity to sort of dream a little bit, just so we're not caught up with yeah. But
I just wanted to know
I
just wanted to know to discuss these kind of ideas, but I don't expect that you teach us to do that.
Oh, no. What I was trying to get at was if you do have ideas which require this, we can sort of propose that, and at least then we can talk through some of the things that could happen. And then you can always get like a robotic integrator to actually do it for you, right? Because well, our skill sets are also limited as architects.
Yep.
Right.
So I'm seeing Karl already with us. Karl, do you mind if we spend another like 5 to 8 minutes just discussing real quick a few things that we have to cover, and then we give the floor to you?
That's no problem. Whatever you guys want.
Okay, and then I can properly introduce you. Okay, thanks a lot. I'll go briefly through just some examples, some inspirations, and again, really, you can think about like even more complex processes, and then like express a concept. That's totally fine. You don't get crazy in one day, like trying to figure out all the scripting. But here's one example. A student in Bologna trying to imagine, how the robots could occupy factories in downtown, in cities, and how these processes could work. So this is just like speculation in general of the occupation of robots of the cities. More from the same portfolio, just in terms of imagining, like one element, one morphology, and then trying to express that in architectural terms. So scaling up this and try to put elements so that we can understand the scale, the dimensions of the object, and that could be one way to look at these things. I'm going a bit fast, just great example from 2012, flight assembled architecture from ETH, in which if you look at the videos of this experiment, it's funny because it's very loud, it's very noisy, like listening to all these drones taking off and landing on like the following layer of bricks. But what was compelling here was to really to push the imagination and creativity and try to imagine this system, this tectonic system, as an assembly of, like larger scale system that could be like a building, a tower composed of like these elements that we're seeing here that we can interpret as sort of a scale model for this kind of idea of city, idea of assembly of dwellings or like architectural elements.
And it's also a great example of what Espartco was talking about 2 days back, and it aligns really well with that concept of transporting stuff as either a building block or like larger structures in general. And sort of, I think they even literally just like 2 days back is when Gramanzi Okor unveiled the clay wall that they recently made. So I think it's really, I would recommend you guys, highly recommend checking that out, just because I think it would be a good speeder point for sure.
Yeah, more from them. One reference made by robots, architectural design. Scale models, so a workshop session with students creating large scale objects, like in terms of study objects that could be seen. And actually, as part of it, this is the script, how the pick and place script might look like when you really are managing like the transportation of every single element and like put it into place to create a final model. And translating this idea, this model, this object into an idea of city, an idea of land of occupation in the urban landscape.
And also in terms of speculating how these systems sort of come together, what we've been looking at throughout is robots on the ground. So don't limit yourselves to that. I mean, if it means you put them on the ceiling so that it gives you more area underneath it, like something ETH does, or just to explore different positions even. So let's not be, if that's something your project demands, by all means, make it as speculative as possible.
Yeah, or even imagining a population of little guys hanging out on site and imagining really this is an example, speculative example that ties to the work of Gilles Ratzin and Molly Claypool in London. They talk about discrete architecture and how to assemble it. So starting from small architectural units and combine them and assemble them, and to imagine really a swarm of robots coming together, and each one does sort of a collaborative task to make the construction happen. And you can see also some testing in their fab lab. More of this. Another different approach in terms of like carving foam, different sort of hot wire cutter that allows you really to create patterns for on an initial volume, in this case foam. And we can imagine this as a possible fairly simple submission as well, just to imagine a tool path and to expand this into like a multiplicity population of forms, in this case columns. Push your creativity if you want to locate this somewhere else in terms of like moon of Mars or other planets. More than welcome to look at these things as well. And really in this case, as you can see, the base geometry, the base idea is a pattern basically. And then from here, we can really just imagine placing the robot on site and try to produce some sort of colonization, planetary colonization as well. And so I left this as a last comment, knowing that Karl will come here today. This is actually one reference that he found from Lebos Wood that talks about the fact that in a manifesto that, and we mentioned some of these things already, just putting scale models in a model that is scale figures, sorry, in a scale model doesn't make an architecture automatically. Then we have really to think about electronics, materials, even smaller scale elements like handles and railings and these kind of things. But in this phase, we keep talking about like early stage phases of design. We are speculating on things, we're creating small objects, and we're trying like to build skills also to imagine these objects becoming something bigger, a bigger example of architecture. So I'm just leaving you like for this exercise with this reference as well. And before giving the floor to Karl, I just would like to show you quickly something in the case files for day 5. You can find a bunch of scripts that I'll just show real quick in terms of approaches. So we don't have time like in 5 days to cover everything. I told you like so many and the factors, but I left here some stuff for you to explore if you want to look at 3D printing, for instance, or if you want to look at pick and place exercises. So in this case, let's start from this. I'm just showing the simulation. You can look at the script. You guys have some already some good grasshopper skills, so I don't think you will have issues trying to see and understand what's going on here. But basically, if you want to include this in your process for this last exercise, we are more than happy to see this deployed as well. So if you want to imagine like using this script as like a demo, as an example, a case study, and then you can, create an articulated parametric wall or something that is like composed by discrete elements, feel free to do that. In this case, as you can see, the gripper is not opening or closing. We're assuming that sort of it's a vacuumed kind of tool. And that has, and by the way, the input should be into Kuka PRC. analog and digital inputs, analog output, digital output. Those are those elements that you need to, first particle for your previous question, to include in the script to have that relationship between like the robot and other external inputs. So that's one script is for you. It's just as a workshop material. Another, sorry. 3D printing.
Oh, and what's great is, yeah, we've been talking about so many different processes, and we looked at wire cutting, milling, and other things. I think it's also a good opportunity to sort of marry the two, or like cross-pollination between 2 or 3 different processes that might help you come up with different outputs in a lot of ways.
Yes, exactly. And in this case, we have 2 different approaches on 3D printing. In this case, you'll see 2 robots just because I really wanted you to look at like the same 3D printing process deployed in 2 different ways. In this case, through by using the contour lines, and those are just parallel offsets, and you can control here, in this case in millimeters, the thickness of the layers and what you can have. And then you see basically the robot with a generic, in this case, generic tool and effector, sort of completing an extrusion process, as you can see. So like I'm going from the bottom to the top of this object. So I'm imagining this to be a 3D printing process. Slightly different approach in here. Hopefully from the preview, you can see that. It's basically a spiral. Instead of having, you know, parallel layers and then you hop on the following one. In this case, it's a continuous line that goes as a spiral. So it's a bit more sophisticated. Just for you, take a look if you're interested. Sorry, in this exploration, it's here. Right, so you don't have a jump on the, you might notice here that it's inclined line, so that it goes with that pattern. Last thing in here, you'll see, for those that don't remember who asked me this yesterday, to try to understand better what it means, you know, to set a tool, you'll find a PDF, a workshop material that tells you how to set a tool. It just means like to take the teach pendant and to plug some numbers that need to match with the numbers in Kuka PRC. Sorry, it's a bit blurry, this image, but I think it makes a point of like really these things should match. And when you set the end effector in Kuka PRC, it means that you want to control these, the way the tool reference system is approaching the target points. So I made the visualization of this plane bigger. So if you guys want to, you know, to experiment, you can, sorry, I opened this here, but take a look at this and take some time to understand rotations. For instance, I only have 1 point in space. I'm reaching that point. And then if you want to change the rotations, and again, imagine that when we rotate Y, sort of, you know, you're addressing the tool in this direction. And so if I plug here 90, right? And then I have this condition. Similarly, if I can put negative 90, and then you have the end effector approaching the point in this way, but we can even do rotate, let's say this, or I guess maybe the C works better to understand. Right? And so it's really, it's a geometric thing. It might take a while really to get into that logic. So maybe this file will help you. And of course you can rotate things also, I don't know, 45 degrees, not necessarily you have to stick to the 90. It depends on the script. It depends on the toolpath, on the end effector. And one thing that I wanted to mention is that, and that's really the last one. So these arrows correspond to these arrows here. So the first one is the Z, this one is the Y, this one is the X. Those are important because with the teach pendant, we haven't tried that, but you can really address the robot following this coordinate system. So if you press the Z vector, the robot will advance in this direction, like will proceed following this vector. So it's not following anymore, the world coordinate system. So you're controlling the end effector. Those are the things that I wanted to mention. Take a look at these files. Those are for you, and just for the purpose of understanding these things more, understanding a wider range of end effectors. Was a bit long, but I really look forward to introducing. It helps a lot. Okay, awesome. Thank you. I'm glad that helps. So let me find the introduction for our guest lecturer.
Oh, by the way, I found that file that was intersecting with the wire cutter and the tool pathing. So I'll just put that on the drive, and then we could possibly come back to it tomorrow or later towards the end of the session.
Which one was that?
That's that was on slide 12, where we were trying to sort of where I think the frame was coming really close to the robot. So a similar example was done at LTU. So I'll just share how they sort of tackled that by rotating it about 90 degrees and tweaking the geometry a little bit. So I guess this is more for the student to sort of take learnings from that project. Sure. and reconfigure the tool paths. So that should make things easier for you, Jeff.
Okay, if there's a new file, like just let's make a folder that says like new files or something, just so, because we downloaded them all already. So yeah, thanks.
Sure.
Great.
All right.
So
hi, Karl.
Are you with us? Welcome back. So it's great to have you here. Thanks for your time. So for you guys, so I think Karl, you already know like the context. You know that we have some international students, international participants here in this Digital Futures workshop. So for you guys, Karl is the Dean at the College of Architecture and Design at Lawrence Technological University, where he is responsible for degrees in architecture, interiors, graphic design, game art, industrial design, car design, and urban design. I think I mentioned them all. Just to mention.
Game art is now game design as well. We changed that. Everything is design.
Right. Karl taught for 17 years at the Daubmann College of the University of Michigan, where he held a full professorship with tenure and where he served also as associate dean. He did his B.Arch at Roger Williams University, his Master of Science at MIT. In 2015, he was awarded the van der Rohe Prize that allowed him to spend some time at the American Academy in Rome as a research fellow. And I think he will show us some of your work from that period. He has a long experience as an architect, designer, educator, administrator, and leader. He's engaged with emerging trends and he uses all the available data to transform organizational cultures in a responsible, respectful, and financially sustainable way. He's a former partner of Pi Architecture, and for more than 10 years, Karl co-authored a broad range of work exploring design and digital fabrication. The work of Pi has been published in the US and internationally and received awards for both build and speculative projects. Pi was also named one of the 101 most exciting new architects of the world by the Wallpaper magazine. Karl has served as the head of design at Blue Homes, a technology startup that builds modern green prefab houses that fold for shipping across North America. He managed a team of 60 people in multiple locations, and the work of Blue Homes was published, among others, in the Financial Times, in Dwell magazine, and multiple times in Forbes. In his career, Karl has given impactful presentations to promote design, and he advocates for enhancing in the architectural curricula the value of multidisciplinary design, digital media, and robotic fabrication. So thanks a lot for being here with us. We're excited about robots.
Yeah, so nice to see you, Karl. Thanks for doing this.
Thanks a lot. The floor is yours. That's super exciting.
How long do we have? Hard stop at 9 or?
Let's say 40 minutes. And then some
yesterday
questions.
You told me you wanted an hour.
Sorry, that's my fault.
All right, let's see what we should do. You can see that, right?
Mhm.
No, I can't see you guys. All right, you can see that? Okay, so I guess maybe I'll talk about a few ideas, and then I brought 3 projects, but maybe the projects, we'll do those quickly or whatever. So thank you for that introduction. It's nice to welcome everyone to LTU. It's nice to have Bianco being used in the summer. And it's also nice to maybe expand on some of these ideas and think about what it means, what robots might mean for the profession of architecture, and even more broadly, what it might mean for design. So maybe as an introduction to talk about some of these things, I really, and actually I'm probably going to reference like 5 or 8 books throughout the lecture, and then at the end I even added more slides I took out, but other books I might reference in relationship to these. So maybe I'll share a PDF or something with Sarah, and she can share them with all of you if anyone's interested in more reading and more things related to this. I really like Robin Evans. Well, in general, I like Robin Evans' book, Translations from Drawing to Building. And like Sarah said, there's a number of design degrees at LTU. And one thing that I think unites all designers is the fact that in some ways we don't make things. And that's a bit of a provocative statement, especially coming from someone who's an advocate for design build, and I've done a lot of construction myself, but in a kind of traditional or typical sense, a designer thinks about things before they're made, and a designer has to understand all of these issues, and then often must communicate these things to someone else, or in this case, I'll also say something else. So someone else might be engineers, fabricators, contractors, whoever that might be. Something else might be 3D printers, robots, other types of things. And so there is, when I use the term disembodiment and disembodied craft, there's a bit of an oxymoronic relationship between that, because the notion of craft always comes from some kind of tacit understanding about how a craftsperson uses her hands to make something, right? That we have that direct engagement with a material. Architects and designers are separated from that, sometimes through geography, sometimes through time, and most often through responsibilities and organizational structure, right? That it's not our responsibility to personally craft those things. We communicate to others. So what does this mean as we think about our discipline of design? There's a long history of these things, and I'm kind of interested in these trends and how they're evolving and how they're changing. But I teach a class in Grasshopper. I've taught digital fabrication, I've taught parametric modeling, and I continue to come back to this example from 1535, which in a lot of ways might be considered a precursor to mass production. And graphic design, the production of books were mass produced long before other more complicated mechanisms or other types of things. And so Durer's alphabet is I would describe this as a script on the right. So the letter E is a text description of how to construct the letter E. And so I use it as an analog for construction documents to some extent, right? As architects, we use construction documents to communicate to a contractor what to build, not how to build it, but what to build. And in this way, we see from this description, this kind of script. And I also specifically say script because this is a step-by-step procedural description the order matters. And that's exactly the way that we also work with Grasshopper. And so I think if there's any questions along the way too, feel free to put them in the chat. Feel free to ask a question along the way too. So I like these ideas, and another reference for someone whose work I really appreciate and whose writings I really appreciate is Annie Albers. Annie Albers is a Bauhaus textile artist. She was the wife of Joseph Albers, the Bauhaus painter. And she talks about this thing as that very often or typically design is understood as how we impose form on a material. And I think that's a pretty common thing. Even in the way that we set up most design process, we start at a large scale, urban scale, a site scale. We refine and define a form. And then at the end, we choose what materials those are. And she suggests flipping that. And because materials, and I would say process, has things that it can tell us. And often if we think about defining the form first, and I had a colleague who always talked about design as like form descends on material. And if we flip this, we can kind of listen for these things. And what she describes is kind of listening and being receptive to the materials. And I would include the process for that. And so what does this process mean? What does it kind of look like? What are those trends? The other thing, I love Louis Kahn's work, and he made this distinction between form and design. Form is what it is, right? That's the kind of shape of it. Design, instead, though, is this circumstantial act. What's your budget? What site you're working with? What client you have? How much information you have at that point in time to make those decisions? And so design becomes this very kind of open kind of condition where we learn more through the process. And I always love this idea that there's another author that I like who described Da Vinci as not learning how to paint, but painting in order to learn. And I certainly describe design that way, is that I'm trying to learn about the world and take on specific issues through design projects. And the design projects become a form of research that produces new knowledge. And so let's talk about some of these trends. This is an image that I've been using for many, many years, even before I moved to LTU. And this is one day's production of Model T Fords in probably the early 1920s. And so this incredible manufacturing landscape in Detroit. Come to find out, the Lawrence Technological, or at the time, Lawrence Institute of Technology, the first building was just on the other side of this building on the Ford campus. And so the institution now that I'm responsible for leading grows out of this industrial production and this industrial landscape. One of our, or many of our alum work at Albert Kahn and Associates. Albert Kahn was the architect responsible for all of the buildings that Ford was building. And so I often talk about this reciprocity between what was happening at the time, this kind of mass production, being mapped to architecture, right? That the repetition of that industrial building is informed and infected by these ideas about mass production. So this is something that we're so steeped in these days that it's cheaper to do the same thing over and over again. But what I think is also important to know is that prior to 1798, everything was custom. And so we're going through this kind of pendulum swing of prior to 1798, and that's a very specific date. That's the patent application for Eli Whitney to US Congress to make interchangeable parts for rifles. And this is the kind of history of manufacturing. And so prior to that, everything in the world is unique. There is no mass production. There is no repetition, right? Then we fast forward to the 20s with Ford. We fast forward to the 50s and 60s. And now we're used to this idea that it's cheaper to do the same thing over and over again until the 90s, when there starts to be a discussion about digital fabrication. Now with robotic production, how do we start to understand customization, mass customization, and how does this inform our profession and the way that we work and the way that we think? And so some of these kind of long held beliefs are maybe not that old. And so this is something that I kind of think about, operate within. On the left-hand side, that's the Model T plant. In the middle is the transformation of manufacturing in the automotive industry these days. And so if we talk about robotics, robotics comes from these types of manufacturing sites. And it's important to think about the differences between a manufacturing site and a construction site. These places are radically different. And we're starting to see things like Boston Dynamics and the Spot as technologies that are more able to navigate the unforeseen circumstances of a construction site. The image on the right was, and Sarah mentioned, Blue Homes. And for 4 years, I was the creative director and head of design for Blue Homes. And that was our manufacturing facility, is the image on the right. And so I got to play these ideas out at the scale of housing in the US, single family housing. So a really fascinating thing. I'm not going to talk about any of that today. That's its kind of own thing. But as we start to look at these types of issues, I always talk to prospective students and prospective designers when they're starting out their career with everything that we're seeing in terms of any repetitive task will eventually move to being created or controlled with an algorithm or turned into some type of robotic aspect. And we're seeing this in lots of other sectors in the world. But creative work is one thing that will be the last. I'm not going to say it's never going to be automated. I think there are lots of tasks that we do as designers that should be automated. But the creative, the really truly creative work that we do as designers may never be automated. And so it's a really great way or great place to be working, to be thinking about creativity. And I actually think that the more work that moves to standardized, rote, algorithmic work, the more it will force us to be more creative. And so some of these things play out in different ways. And I often talk about labor and other types of issues. And so just as a really simple comparison, on the left-hand side, and I actually had a student, I talked about this the other night in class, and a student who talked about the sari as a different thing that I should add to this. But as a comparison, the kimono on the left values the material more than it values the form that comes at the end. And you can see the black on both slides is essentially waste. And the waste from the silk for the kimono is still usable because it produces those strips, right? So there's essentially zero waste. On the right-hand side, from the notion of the French dress or the art of the tailor, this is a scenario, and I would say this is a problem in most first world economies, probably all first world economies, where labor represents 60 to 80% of the cost of construction, not the material. And so what we see in the production of the dress on the right-hand side is that the form and the way that it deals with material favors labor over material, and it produces a bunch of scrap because that material is a small percentage of the cost and the scrap is an even smaller percentage. So it's basically just becomes disposable. So I think there's lots of opportunities as we think about sustainability and other types of issues to recapture material, to think about material in a different way, as well as designers, we have to understand labor. And that's something that's a kind of intangible thing that we often can't deal with in school. The fact that we're separated from the construction process means that we don't even understand those labor costs at points. And so this kind of recapturing or this notion of the master builder is one where it's kind of interesting that we can flip the script and we can use robotic fabrication to have a direct connection with means and making. Same thing goes with the hand. If we talk about craft, this craft is inevitably tied to the hand, that we get a direct feedback from a material to our body. And so how do we start to think about these things? There are ways of getting feedback from the robot. as it deals with the material, as it engages material, that there are some people working on kind of algorithms that will adapt while they're putting things together with robotics. I'm interested in connecting this loop in a way that we can get feedback from construction or fabrication or manufacturing as a way to make design that much smarter. And for me, there's that kind of evolution. I said I was going to reference a lot of books. This is a really wonderful book called The Hand, anyone that's interested in craft. But I extend this to thinking about robotics. And so the way the hand evolves in evolutionarily, I think the robot then can also extend the dexterity of a designer. And so there's an evolutionary jump that might happen for us with that. So a couple of projects. So I brought 3 projects. I'll talk about them kind of quickly. Not all of them driven by robotics, but ways to kind of maybe extend some of these ideas. So one was a research project from a couple of years ago called Rules of the Road. And I was interested in this from a parametric perspective and the kind of rules. And as I said, having been involved in prefabricated construction and shipping houses all over the US, as well as flying between Boston and Ann Arbor and Detroit and California, looking down as I was flying over the US all the time, looking down, and one of the most prominent things you see is the US highway system as this incredible piece of infrastructure. So I was flying it over to move between my offices, and then the houses that we were building had to be shipped on the highway. And so it was all of these kind of embedded rules that I was really interested in. Historically, where does this come from? How does it work? But I was really interested in the way that rules produce form, and the way that, like the Annie Albers issue, the way that constraints, that really good designers navigate constraints, and we work with constraints. And so, as well as the evolution, the rules should change over time, but often they don't. And so just looking at the difference in the design of a car, safety issues, performance issues, efficiency issues, style, culture issues, all of these things evolve. But we're stuck with a highway system that was designed in the 40s, but now we have different constraints. What does that mean? Turning radiuses, speed, sound, all of these performance characteristics might be changing. And I was interested in the relationship of architecture to the highway system. And what does it mean to design a building based on the highway system and vice versa? And what happens with, say, electric cars and other types of autonomous cars? Can architecture and infrastructure begin to grow closer and closer together? This was a really interesting precedent from 1973, that they were actually proposing that computers could be used to design the highway system. And so just like, a research paper, but really forward thinking as it relates to that. Issues that I had to contend with shipping houses on backs of trucks, that the highway overpasses, all of these dimensions govern manufacturing constraints. And so if we think about the movement of goods and logistics, and the way that these things change, many of these things are tied to the highway system. And I also point to this, just, it's a reference to the highway system, but our design tools. And so this kind of evolution, and we're not seeing this yet in our design tools, but if we look at this trajectory, on the left-hand side is a paper map, and 20, 30 years ago, if you were to go on a trip, you would call someone, and you would call AAA, they would print out all of these pages, they would highlight the pages, and someone did that manually. And so as you went on your trip, you would flip from page to page to page. That went away a long time ago, and that's great. The middle stage that we see was when you would download a map, and you would at least know where you were on the map. This has then also changed. And I'd say maybe that's where we are in terms of design tools. But then if we look at, say, something like Waze on the right-hand side, these conditions are also dynamic. There's a speed trap, there's an accident, and you can be rerouted around those things. So I'm already projecting this notion that before you drop a specific product into your BIM model, it's going to tell you how many other designers already picked that tool today, how was it used over time. The customer has been really happy with that product that was specified, right? We can get a lot smarter with crowdsourced data, and we're not yet seeing this in design tools. And so that's something that I'm interested in terms of crowdsourcing some of this knowledge and being able to share these things. So I was looking at the highway system. The first project that we did was in Chicago. The second project that we did was in Detroit. And these are interchanges where two highways intersect, and then you have to be able to move from one to the other. I think they're beautiful, maybe from 30,000 feet from an airplane. But the way that we think about connection, there's almost a kind of tectonic quality to these. How do we connect these two different parts? And so we started drawing these and trying to understand those constraints and starting to look for opportunities to make space and buildings and landscape between them, and started to uncover these issues within the city. This is Burnham's plan for Chicago. And what's incredible is that this kind of, and it's not unlike the plan of Detroit in terms of having this kind of pitchfork, but Burnham's plan had this incredible civic space that's located here. They cleared out the space in terms of the preparation of the plan, but it coincided with the production of the highway system. So what results is actually that civic space has become, and I don't actually have a good picture of it in Chicago, but it's what's called the spaghetti bowl. It's a desolate, empty space that's a string of highway that just moves through that. And so it's this disparity or this discrepancy between the scale of the highway and the scale of the city. These two things don't always go together. And so we looked at this as a site for a building and used the constraints of, and tried to reclaim this huge space, which is just infrastructure, for a civic building. But also tried to reclaim the kind of cloverleaf aspect of how do we think about a building organized this way? What does it look like? How does it do these things? And so this was a kind of proposal. We can see the Sears Tower or Willis Tower in the background and its relationship to that as we cut through thinking about how the infrastructure may move around, and then a public space, landscape space in the middle. Another space that we looked at on the south side of Chicago was a connection from one highway to the other that essentially bisected this community. And so taking those kind of rules, shifting the highway, moving it over, being able to slow things down, and starting to think about what's the proximity that we can create with these things. And again, thinking maybe the highway can be a beautiful thing if it's not noisy, if it's not spewing pollution, if it's not doing all of these things. How might these relationships begin to change with that? And so it's really a study in parametric design, but again, highlighting the fact that these kind of constraints, and many of you have been working with constraints this week with robotics, the scale of these things. What are those dimensional constraints? How does it rotate? What space does it fit within? Going back to that Andy Albers notion, how do we learn from those things? How can those things be productive and start to set limits for us? Designers need constraints and limits. That's how we work. That's how we think. And so a second project, maybe more closely tied to some of what you're doing this week, was a project that we did, also a research project called Robo-Pinch. And it comes from, this. So I changed some slides this morning, but I'll start here and say, this was an analog project that we did in a design studio where the students were working with plaster. And one of my research assistants who was in the studio at the time was casting these beautiful models, but by hand. And she was holding them. The plaster took a while to cure because it was in a balloon. And so she was making these incredible models with her hands. And so this is the kind of craft-based aspect of that. But what we wanted to do was take this kind of learning and this kind of feedback and the input of the hands, and imagine that instead as grippers or other types of parametric control through the use of the robot. So if I go back a couple of slides, these are some of the things that are at stake. Another really useful book, if I assume all of you are interested in robotics. So the notion of the fourth industrial revolution is something that's kind of changing. If we look at the impact of Henry Ford in that industrial revolution, the change of robotics, biology, these kind of big physical, digital, biological trends are going to change this kind of landscape that we know. And so Klaus Schwab put together this really great, simple, small book called The Fourth Industrial Revolution. And these are some of the issues. And I know that Sarah and Misri have probably talked about Ballard International. And I hold up Ballard as a really, really interesting place that I describe as a halfway house on the road to the fourth industrial revolution. Justin buys robots from capital intensive industries like the automotive industry by the hundreds, if not the thousands. And then he resells them to mom and pop shops or schools and other types of places like that. And so we get hand-me-downs from the automotive industry, but we can use them in very creative ways. And so these robots are finding a second home in new types of industries that can really deal with mass customization. And so it's not unheard of that a cabinetry shop, a countertop shop, a small fabrication facility will have a robot. And so we're in a really interesting place as designers learning how to use robots to be able to engage that type of industry and in a way that will never be able to engage the automotive industry. They're set up in the old model to keep doing the same thing over and over again. And so this is an exciting thing. We can see that, and this is, I know Sarah dealt with this within her dissertation, rising labor costs. Like I said, any first world economy, the labor is going to be way more than the material. But what starts to happen when our labor costs rise, people are leaving the construction industry and robot prices are dropping. And so for a long time, I was saying there will be robots on construction sites. I said this more recently among a number of alumni and architects. They're like, well, yeah, there already are robots on our construction site. A lot of them doing brick, a lot of them doing other types of things. And so this is a trend that is going to continue to accelerate and change the way that we make buildings. This was an incredible example that I came across a couple of years ago, which was a robot that milks cows. And so this idea that robots exist in a really clean place and a really perfect place, like a manufacturing facility, is changing. And so the cows prefer to be milked by the robots. What happens is that, and think about this, the cow steps into this kind of stall. The robot is scanning the udder of the cow real time and latching onto the cow and then milking the cow. The farmer gets all of this data from things that are happening. It's just this incredible thing that happens. And for me, it's like, if we say that there can't be robots on construction sites because it's dirty, because it's unique, because it's all of these things, like I would say a dairy farm, way more dirty, way more unique, way different from other things that are going on. So just really interesting ways. And not to get too much into the robots, the dairy farmer can't find people to work on the farm. And so this isn't a displacement of labor. The farmer just literally can't find people that want to do this work anymore. Again, a kind of first world problem. And so the robot becomes a way that it's not putting someone out of business. It's not harmful to the cows. The farmer cares very much for his cows. And so it's changing these sets of relationships. And so what does this mean as designers start to use robots? We're going to use them in different ways. We're going to think about things in different ways. And so this idea of the hand as it relates to building models. And I love this iconic photo from Korb of the hand sliding the unit into the frame. And so what happens if we think about how do robots work with this? Can we design at our desks with a robot? And then that robot, those kind of the scale of those things scale up to where we use the same type of robot. There's robo-dozers to do site work. It's pretty easy to imagine a robot installing facade panels on a building. And so how do these things start to change? The other thing we were interested in is the impact of material. And so I love this Gaudi example of the hanging chain model. And so the connection between what we do with models and an idea, or physical analog models at our desk don't necessarily map to the way that we build things, but they could. So imagine sitting at your desk building a model and building things in the order that they would be installed on a construction site. And so can we simulate a much larger process in a way at our desks? And these were some of the questions that we were asking with RoboPinch, in that everything is made with a computer. There's a connection between being able to output these things robotically. We wanted to use very inexpensive and flexible formwork to produce something, with an idea of producing a series of plaster models. Very inexpensive. 20 pounds of, 25, no, actually 50 pounds of plaster costs like $20. And so in terms of 3D printing, plaster is way cheaper. In terms of 3D printing, these types of models in some ways were much faster to make and faster to prototype. They could also scale up, so that something that you laser cut at a small scale, and I have a class this summer working on this, the same model that they laser cut a physical model with is the same file that we're going to use to produce the thing at a full scale through a water jet. Same exact file. And so the same can be said for going from a use of a small robot to going to a large robot. And so here's where the Gaudi comes in. If it's a fabric formwork, if we turn it on its side, gravity will cause this to slump. If we stand this upright, gravity will force this to slump in a different way. So form finding, using gravity, using internal pressures, doing other types of things, be able to pinch it or poke it. I guess this is a poke. Pushing from both sides displaces material. It doesn't remove material. So when we're not producing waste, we're just shifting material. If we pinch it and pull it, there are other ways that the material is displaced. And so we started to look at this kind of parametric process of, if we want to poke a material, these were a series of small cube studies that we did, flexible formwork, and just through changing the robot, the simplest code, go to this point or this point or this point, we could produce parametric variation with these things very easily, very inexpensively. And so again, thinking about Gaudi, how do we slump material and not having the problem of Stella having to hold this for 10 minutes while it cures, is being able to move the robots to specific locations and then produce a specific form from this. If we wanted to replicate it, we could have the robots go to the same location. If we wanted to look at variation between these 2 points in space, we could make small incremental changes, and then we could produce different models. These were holding pieces that had already been cast in place while we cast something else in relationship to it. And we produced hundreds of models. And so these were intended to be small analog physical models. They could be replicated easily. They were very precise, but they were also incredibly inexpensive because of the cost of the formwork and the cost of the plaster material. And so we could prototype these things. We could look at them, we could sand them, we could cut them, we could crack them, we could post-process them in a number of ways. And so here's these kind of moments of being able to poke the material and displace the plaster, produce these, what I thought were really incredible forms. And at the time were very, very difficult to model. Now, through subdivision modeling in Rhino 7, Gravity Sketch with subdivision modeling, many of the forms that we are creating here are much easier to produce digitally. We didn't have digital models for these. The only thing that we modeled was the action of the robot. The form was a direct result of that. And so we started to think about them as architectural models, the inclusion of small scale figures, beginning to think about landscape, space, volume, other types of things. And so we saw these as a kind of proto-architectural scale for this. And this was the exhibition of this work at the end. And we can see all of the studies that were done in the way that it was exhibited, and then a series of more final models on the top that were lit in kind of very specific ways. So this was the thing, being able to, as designers, being able to produce lots of variation. And that's a really amazing aspect of the robot, of being able to refine and change some of these parameters to produce something else. And so this project as well as the next project are both in a book chapter for what I think is going to be a great book. There were some great people included. I think it was from an exhibition and symposium called Body Object Enclosure. And I think that's going to be out in September. Some really amazing people involved with that. So then the last project, I'll do this quickly, was an opportunity to go to Rome and live there for a year. And I think you're getting a sense from my fascination with rules and constraints. And my proposal was to go and study Borromini. And what I was interested in with Borromini was that he trained as a mason before he became an architect. And that relationship to craft and rules was something that I wanted to extrapolate. And basically the tagline that I proposed was, what would Borromini do with a robot? And so starting to look at him historically, people writing about him and talking about this kind of variation and like ruthlessly logical types of variations that were produced with him. And from my understanding now, that comes from his training as a mason. Embedded within the drawings are these kind of aspects. And one of the things that I did is I built CATIA parametric models based on his drawings. And so embedded within the drawings, if you use a compass, right, in the old school, the compass makes a hole in the sheet of paper, and then you kind of swing this thing around and make a circle. The reality, or the analog full-scale relationship to that, is that you drive a stake into the ground and you have a chain, and that's the way that you make a circle on the site. And so Borromini's drawings, in a lot of ways, are the performance of the site construction, but at a smaller scale on a sheet of paper. So how do you locate this point in space? You do this. Okay, how would I locate that on a site? And he understood these things back and forth. And so I love this way of drawing the way that we would construct something and embedding that within the model. And so for a couple months, I spent the time visiting, measuring, documenting, and beginning to model some of the Borromini spaces that were around me in Rome. And embedded within the parametric model were those rules and those constraints. And then what I looked at doing was beginning to relax those rules. And so, does it have to be bilaterally symmetrical? No. What happens if that changes? What would these things produce? And so there were these drawing / 3D prints, the whole series of this analysis work that came out of this. You can see some of these details, the drawing, and then the three-dimensional form. And then using that parametric data to kind of produce some animations that showed this is a kind of common motif that he used called the quatrefoil, which is 4 concave and 4 convex radii that produce one shape. But again, these are bilaterally symmetrical. And so from that, what happens as these things begin to be relaxed? And so going from a kind of Borromini example on the left to almost what looks like one of the alto vases, right, that we're all familiar with too. It's like same rules, but some of them relaxed and allowing these things to vary and change. So I think there's a lot of opportunity to reclaim old algorithms or old rules and start to look at how they might evolve and change. And then three-dimensionally, what happens as some of those rules are relaxed. And one project that came out of this, we've got a couple minutes left, I think, is just the production of a set of, I was really interested in the hand, and I referenced that earlier, the notion of the hand and how we work. And so living in Rome for a year, I was also eating a lot and started to make this connection between the scale that I was working at of this analysis and pasta. And so what came out was an investigation in pasta. And let's see, I know there was a chat, but now I can't see it with everything else.
I'm just saying you can run a bit longer, just because the recording will remain online anyway and on YouTube. So like, if
Okay.
you want to take a few minutes
Okay.
more, it's fine.
I guess I have to, right?
Yeah, it's okay.
It's not, but I can go quickly through these. So that my interest in labor, so my interest in the hand and my interest in labor became a way to test some of these things, as well as creativity. How do we as designers enter a space that we're not typically in? For me, at this point in time, it was the kitchen. And in the kitchen where I was living, it was a kind of sustainable Roman food laboratory. And so I began to use my design project as a way to, one, get into the kitchen, to collaborate with the chef, and to think up this type of project. But I was interested in that notion of I'm not going to make the food, but how do I design a process? How do I design a tool to help make these things? And so I had to learn about how you make pasta, the chemistry, the structure of it, the process of it, all of these types of things. And so this was working with the chef in Rome, and how every Wednesday they made pasta. Every Wednesday I would show up with a new tool and we would try it, and I would get feedback, and I would go back and I would 3D print a new tool. And so these are traditional pasta presses, brass typically, and wood. And so looked at traditional tools and how these tools are used, and what I was thinking about doing. And this was an initial model. And over time, starting to add more rules and more constraints to this, like the draft angle, like the radii, looking at the structure, looking at all sorts of things. This was over time embedding more and more of that knowledge into the parametric model for the production of, this was one of the pasta shapes that we were going to produce based on some of the Borromini rules. And so over time, what I want to show is a series of iterative tools in terms of this pasta press that I was developing. And so, and I'll show you the problems as well. It's like, this was one and the pasta got stuck inside. Okay, how do we work through and change that? This was another example where the draft angle, and I mentioned this here, the difference between this surface and later on controlling that surface and being specific about it had to do with these types of issues, right? Those two surfaces were too close together and sheared the pasta, or it stretched too much. And so controlling the thickness of the pasta, and imagine going into a kitchen and saying, all right, we need to roll out the pasta 1.25 millimeters thick in order to get this to work. And so I think I have a picture where they had a ruler and we were testing the thickness as we were rolling out the pasta. This is a section through a different form, registration pins, and then even you'll see this little part as it comes down, trims the pasta. And so the way that the models got smarter over time, and this is that, 1 millimeter thick, but it started at 1.25 millimeters thick, and then it gets pressed and squeezed. And so here we can see measuring the thickness of the pasta. And then these were the three shapes. And so this is San Carlino, San Ivo, and Santa Maria Sette Dolori, three Borromini churches, and then these pasta presses that we produced. Over time, this also changed considerably, like working with great collaborators. It's like, this was a pasta dough that had egg within it. And my collaborator was like, well, but Borromini's spaces are white. What if we looked at a different dough mix that didn't use egg, that used oil, and then we could get a whiter pasta? And so you can see those kind of the material experimentation that was happening. You can see all of the prototypes in terms of the way each week labeling these, numbering these, dating them, so that we could learn as we went. How we cut it, you can see the registration pins, and then starting to produce these. And this is that offset of the labor, right? That not made by robot, but having to understand who or what is going to be building the thing, and how do we inform that? How do we design these things? And so this was looking at the hand, and just the first stage was only controlling the internal piece, but over time you'll start to see shaping the external piece to think about this as a designed object, how it registers, a flat edge and a flat edge. There start to be like thumb holes cut out here, the registration, and then this starts to get shaped over time. You'll see for the thinking about the hand, you can see a portion that's cut out for your fingers. So it really started to specify how you hold it and where you hold it and how you press it together. And so it's kind of evolution of this design process, looking at these things, designing the two halves, how it presses together. These were all done with ABS plastic. The goal is to develop these out of brass and begin to offer a high-end kind of tool to make these. We also looked at the sauce, an early kind of pure version with just butter, a red sauce in a very traditional way. But again, my collaborator said, Bernini's spaces are white. What if we looked at a white cream sauce with a pecorino cheese? And then they also specified a white pepper with that. And so like really designing this thing all the way through. And then I don't think we'll see if I included some of the slides. We also developed a custom plate for the pasta in terms of based on another Borromini space, but how it connected to the table, how the corners lifted up, how you might hold it, how the hand of the wait staff would start to interact with the plate. And so this was the production at a certain point, handing that off to the kitchen, handing the tool off and letting them work with it. And so this was, what we did is we served a dinner one night for 60 people with the Borromini pasta. And so you can see we didn't make custom plates for the 60 people, but this was plating it for that meal. And then Tiziana bringing the pasta out. You can see some of them get a little squashed, some of them get flattened when you hand this off to someone else. But this really incredible experience of both making a meal, thinking about the culture, thinking about the history tied to this, and all the way back to thinking about the kind of craft and production and the rules and the geometry and the labor that goes into this. A lot of the prototypes and the studies here, early versions of the plate, and then the final version of the plate where we worked with a crafts team, a ceramic team outside of Rome to produce, I think I produced like 20 plates in the end for that. And then a more recent version with an idea, these still as the plastic 3D prints, but still searching for the right fabricator to mill these out of brass with an idea that there'll be a custom tray that holds the 3 pasta presses with that. And then some of this work was published recently in a really nice collected essay book called Finding San Carlino. And then it's also, I think there's discussion of it in the book on body object enclosure too, which should be out in the spring. So I didn't talk about the photographs or any other things, so I edited some things out. If anyone has questions, here's my email address. My firm, and what's interesting with some of these things is that Sarah and I are working with a client now to 3D print, robotically 3D print a house in Detroit, or a portion of a house in Detroit. And so that work should get posted over the next year on Daub. Instagram is here, where we're posting things from the school, as well as just recently started a YouTube channel that has a lot of the Grasshopper tutorials and things that are being developed within the class. So there's a kind of range of things, and I'm happy to answer some questions. And then these were, just at the end, if people are interested in some of these larger trends, ideas about technology, a few books. The Inevitable is a really wonderful book talking about technology, and I can share these with Sarah. Refabricating Architecture is an older book now, but one that talks about manufacturing, really great book. Meta Skills is one that I shared before in terms of thinking about how these things change as it relates to the workplace and creativity. Human plus Machine, talking about artificial intelligence and the way that it shouldn't be either or, but that we should find ways to plug in with this. The Design of Business talks about these types of big problems and how we build a business model around them. And range is another one that just talks about, again, these notions of wicked problems versus kind problems and how we learn about them.
Thanks a lot. I think it's very interesting to see how we have some people clapping. As if you have questions, well, first of all, one comment is really compelling to see the level of authorship that you have in your projects, using tools and robotics, but still like showing, making explicit the role of design and the architect deciding really the iterations, and to make explicit the fact that in this case, like we rely on the tools that we use, and you left range of like human sort of input in those experimentations that I think are very compelling. And a communication for everyone. You'll be with us tomorrow, right? To look at the projects. Through the week, we have seen some very interesting submissions. They are all Grasshopper savvy, and so it was easy for them just to deploy their knowledge and to apply with robotic fabrication. And it's pretty impressive to see how none of them have ever used, I think, a robot before, right?
Yeah, that's
you guys
hard to
have
believe, for sure.
Right? It's incredible. Never used Kuka PRC, and hopefully you'll be impressed by the work that they have completed in just like 5 days. And I think we'll have more room for discussion tomorrow as well.
And I think that's an important aspect, is like, I think that Grasshopper, like if you can think parametrically, and it sounds like many of you are already using Grasshopper, the ability, we made the decision, Kuka PRC may or may not be the best tool, but what's nice is that anything that you know how to do in Grasshopper, you can easily move into Kuka PRC. And so starting to understand and learn from this kind of iterative way of making with the robot will then be able to inform the way that you design things. So, you won't use Bianco in the future. You might use a different robot that'll have different dimensions and different constraints, but you can just roll with those and kind of incorporate that into the way that you work. And so I think it's good to get your, I guess I'll use air quote, it's good to get your hands on a robot. I know that none of you are physically getting your hands on the robot, but what I see through the workshop is a really common way to collaborate with a fabricator. I collaborate with fabricators and I may not step foot in their shop. And I was thinking about the project that Sarah and I are working on for the 3D printed house. We've never met the client in person. Never. So we're working on a project in Detroit. We've never met the client in person, and we're going to use robotic 3D printer to build the building. It's like, what kind of world do we live in where this happens now? Until like
was
5
that the
years ago.
aftermath of the pandemic? Is that what resulted in, or is it just easier to communicate that way?
It's just easier to communicate, but it's like, but it also, I mean, I'm in Detroit as well, so it's easy enough to do it, but you don't have to go to a fabricator shop to be able to learn from him or her. And you don't have to, and so Sarah and I have talked about this idea that for our online master's program, we could do a fabrication class, because it's not unlike the way that we often practice now these days. We can still learn, we can still have the connection, we can still get feedback from our collaborators, but we don't have to be in the same space with them. So I love this notion that you're joining from all over the world and you're interacting with Emily and Jeff in Detroit. And I think, who knows where Misri is? I think she's in Philadelphia. Sarah's in Italy. You're all over the world and you're collaborating and learning with using a robot in Detroit. Those types of collaborations are just going to continue. And I think you just have to be, I like to use the PASTA project as a way to talk about how we can design to learn. And so I learned from my collaborators. I learned from the chef, and the chef pushed me in other ways too. And so like the Annie Albers aspect is like, if you stay open and receptive to these types of ideas, what you're working with, who you're working with, all of these things will give amazing feedback and make the designs ideally better.
And Karl, do you want to stay with us another couple of minutes? Because I think that Jeff and Emily are ready to show a demo so that you can witness this process.
Sure.
So I would like to pin their video. I think that they have a script ready to go.
Yeah, we have one that's ready to go, and a few others that we're still troubleshooting just a little bit. But we figured that if people are still on and want to watch the first one right off the bat, we should be able to do that for you. And then others will follow shortly. Sarah, you and I can talk about how we want to record or broadcast those. So let's do this first one at least.
Great. Yeah, let's do this. Thanks. It's great that you're here, Karl, now, so that you can have a sense of what we have been doing these days.
Yep.
Really.
It's also a test run for your master's fabrication class.
Exactly. Yeah, and I'll spend some time. I'll be available to collaborate with Emily and Jeff now to troubleshoot some scripts and to double check them. Which one is this? Karl, we need a rotation platform as well. Starting to make requests here, just like to be able to manage one cut and then rotate the cube. So they don't have to get crazy.
Yeah, and perhaps a small Dremel tool. So next time we can start using Bianco to mill really small pieces. That would be amazing.
Look at this. So those were two cuts. Awesome. Thanks. It's like, done it. I think that the next step will be to document these things. Oh, look at those. We have the positive and the negatives perfectly. Yeah, so we'll talk about the documentation as well. You'll have these available, guys, as images for your portfolios.
So I don't know, maybe Emily or Jeff could also, have you guys shown the tabletop robots to the students in the workshop?
We have not, no.
So maybe if you guys could just turn the laptop, just one of the other things that we're thinking, I think we're pretty innovative as a school, that we have 5 desktop robots and they're on, angle it down so they can see the casters too. So these tables can be checked out and rolled into the elevator and brought up to the studio space. And so that students can use the tabletop robot at their desk in studio to be able to begin making some things. And so the plan is to have a small hot wire cutter on, we have 5 of them. So one is going to be a clay extruder. One of them will have a small hot wire cutter. One of them may have a Dremel. And so that way, this notion of being able to test something at your desk at a small scale will then be able to be kind of tested and prototyped and then brought to a larger scale robot. And so I'll say I think many of us are really excited about the tabletop idea.
I mean, it's a daydream. Like during studio sessions, you can decide either if you want to make models with 3D print with the 3D printers or using the robot. Come on.
It's almost like going to the library in a lot of ways,
right,
to say, hey, do you have a free robot? I'd like to have it for a couple of hours. That's amazing.
Exactly. And so you'll check it out as a reserve system. You'll leave your ID card and you'll get a robot and wheel it down the hall to your studio.
Nice. So
there's all sorts of problems that can come from that too, but we'll figure those out as we get there, right? What are the safety issues? What are the sound issues? What are the other issues in studio? Imagine being in the studio sitting next to the person milling something at their desk. That may not be the best experience.
That don't know if you put that in a cage.
Maybe it comes
you
with
can
its own vacuum setup, like I see a room right underneath it.
Jeffrey, I have a question for you. Do you need any guy to clean the space? I could go there.
Come on over, sure.
Just to be able to see what you guys done there.
Sorry? I'm on my, this is my phone. I can't hear very well.
Yes, I will go there just to clean and be able to see what you guys do there.
Oh, we'll pay you. It's okay. Talk to Karl.
No, Karl, definitely your presentation was awesome, and this this sort of idea, like the fabrication education programs that we as designers be able to know about it, is like our approach to the industry, like the engineers and people like that don't have our kind of tools on design. So it's very important to keep going in that direction.
And I totally agree with you. Obviously, there was a period of time, maybe, I don't know, even 5 years ago, even more, 8 years ago, where it seemed ridiculous for architects to be playing with robots. And it's really when I show the scenario with Ballard International of these hundreds and thousands of robots going from the automotive industry into all of these other cottage industries, it's not far-fetched that as an architect graduating in school, that you may be engaging with a robot pretty soon in terms of your practice. Maybe you're a contractor that has the robot. It may be something else that's happening, but it's not, you're right. The experience that we get educationally, the tools that we use we're finding those more and more in practice.
Yeah, yes, I totally agree. And the industry is open to us because when you knock a door to, I don't know, work there or give your ideas to them to produce things, they are totally open because we are like pioneers in this kind of use of tools.
Yeah, they're finding, some of those fabrication shops are finding it difficult to find people that can do these things. And so, yeah, all of you after this workshop have an introduction to this now. And I also don't think that it's not, with the right guidance, nothing that we're doing is too crazy, right? Many of you, or it sounds like all of you, already know how to use Grasshopper. You're well versed in this idea of moving between something that's digital to something that's physical. And the robot is just another tool that does that. Maybe a little more complicated, potentially a lot more dangerous, but I'd say if you can 3D print, it's the same process in terms of using a robot. A little more complicated, but same basic concept. And so all of you are able to do this now. And what we've done is hopefully Misri and Sarah just have demystified it. I'm sure they've made it fun. They've demystified it, and they've shown you a couple of ways to start that process and to continue from here.
And how are we doing, Karl, these days? So that just to hype the students. Hype, guys! I hope that we made you guys excited. So hype!
Yeah, no, I think we also sort of catapulted the students into AI with Matthias's class, and we were like, what the hell just happened? But I mean, also piggybacking on what Espartaco just said, just since we're coming from, or as being students and like through academia, Karl, I have a question for you, and I think it goes along the lines of how with robotics, you said a couple of years back, it would have been crazy for us to interact. And we found a way to adopt and adapt it through the lens of a creative. But what are your thoughts on where we're heading also in terms of AI or machine learning, because that, or like data in general, because that seems to be like this new obsession also with even when I speak with Brian Ringley at Boston Dynamics or Daniel Davis, who was the director of research at WeWork, their professional experience and sort of the avenues that came their way was through like a self-taught trajectory. But I'm also sort of scratching my head about how academia is sort of adopting and adapting these things that are changing so rapidly in the way we practice them.
Was that in?
There we go. They are changing rapidly, and I think some of, like Sarah and I are teaching a class this summer, and some of what we talk about too is like, and it's a little bit of like a cliche, but getting comfortable being uncomfortable. Any software that you use right now is not going to be the software that you're using in a couple of years. The software is changing quickly. The landscape is changing quickly. The workflows are changing quickly. And so I don't know, this also sounds pretty bad, like don't fall in love with anything too much, because these things are going to change. And so, but if you get used to learning new software and get used to adapting and interacting with these things, I think it sets you up in a really great trajectory. I think I was going to say, yeah, I mean, I think the tools change. I think the fact that we were having students work with robots a few years ago, I think it's because other things are happening in the world that it makes it more likely or makes them more accessible, right? There's nothing in terms of education that produced Ballard International in terms of selling off used robots to someone else. But the more that happens, the more likely it is for designers to get it. And so it's also understanding the kind of economics of this. It's understanding the business models tied to these things. But yeah, they are changing quickly, and we'll see what happens with them. But I think it's also in the hands of a designer, these tools are used in very different ways. And so I think it's also up to us to start to critically assess what they can do in the context of all of these other things and start to push them in different directions. I think it's always, having been at Michigan for a long time, it's also silly that the robots are made for repetition. Nothing at U of M was ever done twice, right? You spend all of this time, right? The value of the repetition is you spend all this time investing in the coding to get the robot to do something, and then you get to do it again, right? It never, in an educational environment, the robot is never used to do the same thing twice. And so that really changes the way that we're using the tools, and that's going to offset some of those things where I talked about the difference of labor and material in an emerging economy versus a first world economy. And so, I think we're still a ways off when it gets to mass customization, given some of these issues. And a robot may not be the best tool unless they become super easy to program, right? We don't even have to think about programming them, because that's time that the designer has spent doing those things. But these things are changing.
Yeah,
and so I think
for
it's
sure.
worth
And
thinking
also,
about.
Yeah, absolutely. And also the kind of graph that showed the labor costs versus machines, and also looking at countries which have really cheap labor, and they just have, so every time you try to sort of superimpose this, and it's funny because this past December when I visited India, I was like, yeah, this is what's happening. They're like, but this guy is doing it for me
Right.
so I guess there's some, it's slightly ironic, but also there's again that notion of the hand. And I was reading The Craftsman by Richard Sennett, and it just puts you in another zone. So guys, if you want to geek out on the books that Karl just recommended, you should absolutely do so.
Yeah. And I think that's true. And I say this, and I'm sure it'll get me into trouble at some point, and I don't mean it in a critical or negative way, but if you can communicate with a robot, you can communicate with a contractor. And so it's like, I was really interested as a designer communicating. I don't speak Italian, but collaborating with an Italian chef and an Italian craftsperson, ceramics craftsperson, right? And it was through sketches, through hand gestures, through smiling, through bribery, through other types of things. And so, right, the protocols of sharing your intent with Bianco, I think also set you up really well to be able to communicate to, might be a craftsperson, might be a contractor, might be someone else. There was a study that just came out recently from Adam Grant, or he posted it on his LinkedIn. He said the number one indicator for learning new computer languages is actually language. It's not math, it's not science. And I'm sure everyone in STEM is freaking out about this, but language and communication is a really important part, right? And that's ultimately what you're doing when you communicate with the robot. How do you feed Bianco this information in a way that Bianco understands? How do you communicate with the chef? How do you communicate with a fabricator? How do you communicate with a contractor? You have to understand what their interests are, what their motivations are, but also what their language might be, right? And communicating with another architect is a very different thing. You can't talk to a contractor the way that you talk to an architectural colleague, right? They'll look at you like you have a hole in your head. And so this is all just like, how do we design something, but then ultimately we have to communicate it to someone else. And that's an important part of what design is. All right, Jeff's gonna cut another one. I need to run to another meeting right now.
Yeah, I was about to thank you and to tell that it's just to tie back the conversation to the notion of the fourth industrial revolution and to see how like you care about like building the culture in university so that the students might be aware of all these trends when they get to be professionals.
Absolutely. So welcome again to everyone to LTU and Bianco. If you're ever in Detroit, come by. You're always welcome. And yeah, I'm gonna be back tomorrow, I think, to see the work.
You want to join in the beginning at 7? Too early? Let us know.
Maybe. Let me know. I'm sure I'll talk to you this afternoon.
Perfect. Thanks a lot, Karl. Thanks for.
All right. Have a good day, everyone.
Goodbye. So are we seeing another cut?
Yeah. So we're gonna do one that it's gonna cut 3 of the 4 planes. It looks good in the software, but when we run the code on the robot, it reaches a software or a limit on A6, which is the end. But it will cut 3 of the 4 cleanly. So we're going to go ahead and do it anyway because that much is ready to go. So we may go back and fuss with the code a little bit later, but we're still going to use an extra block of foam for this, so you can see it.
Perfect.
Which one is that then? Is it Spartacus with 4 cuts? Okay.
All right. Perfect. All right, everyone. I have to jump out for class, but I'll try to jump back in if you're sticking around. Thank you so much.
I'll see you. Bye, Misery. Have fun. Yes, and just in general, guys, I think after this demo, I'll stop the live stream, and I'm staying here. I'm sticking around just to help Jeff and Emily with the scripts, and feel free to stay if you have time or you. Oh wow, that looks warm. Sorry, I was distracted by the wire. Oh, very smooth.
Around 6 right now.
That is an interesting shape with 2 only cuts.
Wow, it's looking good.
This is go toward the next position. So just go to the next one. All right, that's where it stops. Yeah, it hits a limit on A6. So we take it back to the recent.
Yeah, but at least we see this. It's cutting quite a lot though. Oh, look at that.
So it's pretty cool. Our cubes, and to start out with, aren't perfect. So there's a little bit of extra here. But yeah, this one worked pretty well.
Yeah. So I don't know, guys, if it's easier just to rotate the cube while you're there and you rerun the, you know, sort of the third plane 2 times.
I can try to fix the Chico without that rotation at the end. If you want, Jeffrey, or you will review it.
We'll take a look. We're real close to it right now. Like,
all right.
We've opened up all the files, or most of them at least, and you know, in some cases, we need to use some of the sliders to change the offset so that the travel motions between the start of one cut and the between the 2 cuts is a little bit different. Well, yeah, we'll take a look. I actually don't know quite how to fix yours, like in the sense, like, I'm not sure why it went so far to begin with. So maybe we change the start position of the robot or something like that so that it has more ability to turn, because it runs out of its ability to turn on the 6th axis. So
it's about the orientation of the last plane of the cuts. I can modify if you want.
No. Yeah, it's not about the last plane at all. The plane is good. I think that it has to do with maybe changing the start position will be the fix for this one. We'll see. Right. Just so that it has more ability to turn. So if its start position, the A6 axis is at like a kind of a middle number, which would make a lot of sense because it would allow the axis to turn in both directions. It runs out of the ability to turn in one direction. So we might try a more negative number or a more positive number for the start position of A6 and then see what happens.
So at this point, thanks a lot for all the technical details. I'll stop the streaming on YouTube, but I'll remain here so that if you guys want to stick around, we can just continue and I'll help you guys working on the scripts.
Yeah, sounds good.